Chapter 1. The Life of Pi. Pi, which we know as 3.14159, is the constant ratio of a circle's circumference to its diameter, and is one of the most widely known natural numbers that exist today. Throughout its 4,000-year-long history, countless mathematicians have devoted their entire lives to researching this constant. However, its discovery can be traced back to ancient Babylon circa 1900 to 1600 BCE. The ancient Babylonians first discovered pi by trying to calculate the perimeter of circular objects, such as a wheel, as noted from a piece of clay discovered in 1936. The Babylonians believed that the perimeter of a regular hexagon was approximately 24/25, or 0.96 times the circumference of a circumscribed circle. From this, they approximated pi to 3.125, or 25/8. However, despite the Babylonians being credited as the first civilization to discover pi, the ancient Greek mathematician Archimedes of Syracuse is largely considered to be the first person to calculate an accurate estimation of the value of pi. Similar to the method used by the Babylonians, Archimedes approximated pi by calculating the areas of a circle inscribed within a polygon and the circle circumscribing that polygon. By using 96-sided polygons, Archimedes was able to come up with a value for pi that fell between the numbers of 3.14285 and 3.1408. Here's a little fun fact. Archimedes wasn't the only person to use this sort of method. Following in his steps almost 200 years later, the Chinese mathematician Chongzhi approximated pi using a 12,288-sided polygon and was able to calculate pi to 355 over 113, or roughly 3.141592935. Today, the most accurate calculation of pi was carried out by Shigeru Kondo on October 19th, 2011, coinciding with the 336th anniversary of when the long S was first used to symbolize the antiderivative function. Kondo was able to calculate pi to 10 trillion digits, a record calculation for both home and supercomputers. However, the modern-day obsession with pi isn't just limited to mathematicians and scientists. Pi holds a special place in pop culture, being one of the most widely recognized constants in the world, with mentions in Twilight, The Simpsons, and even a cologne named after itself. Here's a little joke for you. Which knight was the roundest at Sir Arthur's table? Why, it was circumference. Why? Simply because he ate too much pie.
I is the imaginary unit used in complex numbers, defined by I squared equals -1. In 50 AD, Greek mathematician Heron of Alexandria is noted as the first to have conceived these numbers when he studied the volume of an impossible section of a pyramid. Impossible because he had to take the square root of 81 minus 114. But he soon gave up, and for a long time, no one tried to manipulate imaginary numbers. The first major work with imaginary numbers occurred in 1545, when Girolano Cardano wrote a book titled Ars Magna, in which he solved the equation x times 10 minus x equals 40, finding the answer to be plus or minus square root of -15. Although this was the answer, Cardano disliked imaginary numbers and said that work with them would be mental torture. In 1637, Rene Descartes coined the term imaginary for these quantities and came up with the standard form for complex numbers, using I in the form a plus bi. He didn't like complex numbers either, and assumed that if they were involved, you could not solve the problem. Unlike literally every other mathematician, Rafael Bombelli was a firm believer in complex numbers, but because he didn't really know what to do with them, no one believed him when he helped introduce them. What he did understand, though, was that I times I should equal -1, and negative I times I should equal 1. Most people didn't believe that either. He also introduced the wild idea, the idea that you could use imaginary numbers to get real answers, today known as conjugation. In 1685, John Wallis said that a complex number was just a point on a plane, but he was ignored. Over a century later, Caspar Wesel published a paper showing how to represent complex numbers in a plane, but he was also ignored. In 1777, Euler made the symbol I stand for square root of -1, which made it a little easier to understand. Finally, in 1831, Carl Friedrich Gauss made plotting numbers popular, and also the concept of imaginary numbers more widely accepted.
The mathematical constant E, approximately equal to 2.71828, is a unique number that can be defined in multiple ways. The value of E is the limit of 1 plus 1 over n to the power of n as n approaches infinity, but also can be defined as the base of the natural logarithm ln, the number such that the area under the rectangular hyperbola from 1 to e is equal to 1, and the unique positive number a such that the graph of the function y equals a to the power of x has a unit slope at x equals 0. Like pi, E is both irrational and transcendental. It is not the root of any non-zero polynomial with rational coefficients. The symbol E was named by Euler, and is also known as Euler or Napier's constant, although the discovery of the value itself is credited to Jacob Bernoulli. The E that we know today is the work of many different mathematicians, the first being John Napier in 1618 on his table of natural logarithms. His table gave the natural logarithms to various numbers, but Napier did not recognize that these logarithms were to base E. 6 years later, English mathematician Henry Briggs came close in calculating the numerical approximation to the base 10 logarithm of E, but still made no mention of E itself. In 1661, another advance was made by Dutch mathematician Christiaan Huygens in explaining the relationship between the area under the rectangular hyperbola yx equals 1 and the logarithm. In the same year, Huygens also defined the curve y equals ka to the power of x as logarithmic, but what we will call an exponential curve today. Although all this work on logarithms was coming close to discovering E, the actual discovery was made by Swiss mathematician Jacob Bernoulli on a study on compound interest. He found that the limit of 1 plus 1 over n to the power of n as n approaches infinity lies between 2 and 3, so this was considered the first approximation of the numerical value of E. The mathematical approximation of E to 18 digits that we know today, E equals 2.7182818284590452235, was attributed to Scottish mathematician Euler. Euler also gave the continued fraction expansion of E and noted a pattern in the expansion. Perhaps the most interesting discovery was when Euler found a connection between E and sine and cosine functions, as seen in something he called Euler's identity.
The Maclaurin expansion for e to the power of x can be read as 1 plus x squared over 2 factorial, and so on and so forth, or the summation of x to the power of n over n factorial from n equals 0 to n equals infinity. Similarly, cosine x can be read as 1 minus x squared over 2 factorial plus x to the power of 4 over 4 factorial, and so forth. And sine x can be read as x minus x cubed over 3 factorial plus x to the power of 5 over 5 factorial, and so on and so forth. When expanding e to the power of ix, this can be similarly read as 1 plus x ix plus ix squared over 2 factorial, and so on and so forth. And this can be simplified to 1 plus ix minus x squared over 2 factorial minus I times x to the power of 3 over 3 factorial plus x to the power of 4 over 4 factorial, and so on and so forth. And this can be further simplified to 1 minus x squared over 2 factorial plus x to the power of 4 over 4 factorial, and so on, plus I times x minus x cubed over 3 factorial plus x to the power of 5 over 5 factorial. Does it look familiar? Well, it should, because the first can be simplified to cosine x, while the second can be simplified to sine x. Thus, e to the power of x can be rewritten as cosine x plus I times sine x. This formula, discovered by Euler in circa 1700, came to be later known as Euler's identity. The special case of Euler's formula when x is equal to pi is the simply beautiful identity e to the power of I pi plus 1 is equal to 0, an equation connecting the fundamental numbers I, pi, e, 1, and 0 in the fundamental operations, addition, multiplication, and the most important notation, the equal sign, and nothing else. Here's a little math joke. How many mathematicians does it take to change a light bulb? And the answer, of course, is negative e to the power of I pi, which equals 1.